Hey there, have you ever had a weird desire to play a marble game where you're just rolling around in a bowl randomly without reason? I sort of had that feeling and decided to create my very own marble game, and for whatever reason I felt like making a video on how I did it and what I went through to do it, which this video is the result of. I honestly don't want to make a super long introduction, but I feel as though I should mention that I'm not a god programmer and this isn't a tutorial. This is a project purely for my own fun and possibly to improve my own game making abilities. But if you know in some way I can improve and or optimize this, or have your own idea on what to add, then please comment it below. Also, I'm going to go into excruciating detail on everything I do, so skip ahead during those parts if you want, but I'll try not to make it too boring. And I know I said earlier that this isn't a tutorial, but if you want to follow it as a tutorial, you can go right ahead. But for now, let's get straight into it. Okay, so, marble game. What does that actually mean? Well, picture this. Your character put into a bowl, and whenever you move, instead of just walking around, you roll around, like in a marble. And you can go off ramps and do jumps, but how do you achieve this? Well, first we need our ball. This will be the part that everyone will see and where our character will be placed into. And while we're at it, let's set the transparency lower so you can actually see inside the ball, and set the material to glass, since, marbles are made of glass. Now we just need to figure out how to get the player inside the ball. This could have multiple possible solutions. We could code a script that repeatedly positions our character in the ball and give it the ball's rotation, but that seems a bit clunky and could result in strain being placed on the server or the player's device. Another reason why we can't do this is because of the latency between the server and the player. Whenever a server script runs, it takes a bit of time for that change to reach the player's client, because its path is going from server to player. This wouldn't be too noticeable typically if the server script isn't doing anything related to the player's character, but in this case it would. So instead, I want to weld the player's character into the center of the ball and force the player to be permanently tripped, so to speak. But before I get into the code, I just want to explain a few things. So, I mentioned a weld before, and for those who don't really know programming in Roblox, then this is probably the best explanation I could give. A weld is an instance that attaches two parts together. This is very helpful when you need two things to be stuck together in both position, which is where an object is in the world, and rotation, which is how it is orientated in the world. The second thing I should explain is the humanoid root part, which is the character's center point and the primary part of how it functions in the game, and for this video I'll just refer to it as humroot for simplification. I want to let the player spawn normally and then turn into a ball on their own accord, which I will do something with later, but for now it's just a preference. For this, I want to make a button on the top right, which will put the player's character in the ball. In the player GUI tab contains all of the GUI objects the player will see on their screen, including buttons on their screen directly and on objects throughout the world. Knowing this, I'll add a screen GUI instance in the player GUI tab, which will basically tell the game to display our button on the player's screen, and in that will be our button. By default, GUI instances pivot to a point that are always at the very top left instead of the center of the button, but we can change this by using the anchor point attribute, which changes the pivot point, and by altering it to the max on the x-axis, we can make the pivot point to top right, which will make it easier to have the button be actually on the screen. If we don't do this, it basically goes a little too far and the player can't actually see the button or press it because it's off screen. And lastly, to spruce it up a tiny bit, I'll add some text just so you know it's ball time. Before programming the button, let's create a ball and place it in the replicator storage for when we need to weld it to the character, so we can simply copy it. I could have just placed it in the starter character, so I wouldn't have to clone it, but then I wouldn't be able to allow the player to become a marble by their own will. And additionally, you may have noticed the server storage folder right next to it, but I won't get into the reasoning why I put it in replicator storage right now. I'll explain it later when it's a better time. Now we can program that button. In a script under this button, we define everything we need and clone the ball. By putting this clone in a variable, we can actually alter the ball without affecting the original, which makes things a lot easier. And after cloning, we create a weld and make the ball weld to the character with it, specifically the humanoid root part, which is why I needed it earlier. Now if we test this, we see we are in the ball and it's stuck to us, but we're just walking around fairly normally, and that isn't what we want. This is where I want to get into the humanoid and all of its properties. So the humanoid sounds like a funny thing, but it's pretty simple and is actually a core part of Roblox games. The humanoid is what gives the player's character life. It controls its health, movement, and even contributes to the character model in some way. But it also has many useful properties. Specifically for what we want, platform stand. It's a fairly ambiguous name, but basically if it's disabled you can stand and move around, but if not, you flop over like a fish. This is basically what's used to make tripping or falling over functions, but for our case, I'll just use it to cripple the player's character, since we don't really need it to move anyway, we just want the ball to move. Now when we press the button, we're crippled and put into a ball, but we still can't move. However, if we start the game above a ramp and then turn into a ball, we roll down the ramp exactly how I wanted to, so mission success! Now we just need to make the actual movement itself. You see, another fantastic thing the humanoid can give us is the player's move direction. This practically shows where the player is aiming to move, whether it can or can't. If you take a look at this example, you can see that our player is moving around, but there's a red ball sort of following them. This red ball represents where the player is trying to move. So you can see whenever the player is moving left, the ball goes left. If they're moving right, the ball goes right, and so on and so forth. This is purely me using the move direction to put the ball in front of the player's path. Now I'll freeze the player so we can get a look at what happens when the player is frozen. You can see that the ball still moves. It's still picking up where the player is trying to move, despite the fact that they can't. And the same thing happens when we go into platform stand mode. And using this, we can give the player some speed. A great upside is this works with every device, so I don't need to make the game work for multiple devices myself. Using this, we can alter the player's assembly linear velocity. And speaking of assembly linear velocity, now, the assembly linear velocity is a very long name, and I'm just going to short it to whatever part I'm talking about plus velocity. So in this case, it's the ball's velocity. The ball's velocity pushes the ball in a certain direction depending on its XYZ components. I won't get too in depth, but just know that velocity equals moving. So we can get the humanoid move direction and use it to move the ball. Now if we test it, we see that it rolls around just like how we wanted it to. Currently though, the speed is a bit slow, so we will multiply the move direction to give the player some more speed. Now we can build ramps, jumps, and the player will just bounce across them. At this point, I was considering building the map myself, but I'm not that great at map building, and it also sounds pretty tedious to do all the ramps, and I'm lazy. So I'ma just yoink one straight out of the toolbox. Some of these are a little small, but this one looks pretty big and has a lot of ramps, so I will just be using this one. Now we have our own fun little playground. Also, warning. I highly advise against using the toolbox as a crutch. It can be very dangerous, as it's possible for bad actors to inject their own malicious scripts that can actually take over your game and put horrible things in it, so the creator can report you and get you banned. The best way to avoid this is to either avoid the toolbox completely, which is what I typically do, or make sure the item you want doesn't have any scripts. You can see if it does or not if there is this has scripts tag under the name, which is what I did. Keep yourself safe and use the toolbox in high moderation. Now, the ball doesn't feel that great to use, mostly because it has a bit of a slow startup, as the velocity we're adding to it is not powerful enough. So we can use this neat little property of velocity called magnitude. The magnitude of a part's velocity is a single number rather than the usual 3 that represents the player's general speed. Think of those old cars you used to toy around in older Roblox games. The ones that had the speed on the bottom and that little speed meter on the bottom too. Now the reason why when you fell off the map or did something like that to generally increase the speed above its usual limit, the number still went up, the player's magnitude velocity. Now using this, we can detect when the player is moving slow and make their speed a bit more powerful until they reach a higher number. This makes movement feel a lot nicer than it did before. So if you had a keen eye, you may have noticed that earlier in my recordings of coding that I had changed the camera subject to the ball. Now, I was planning to go over that in this segment smoothly, but I kind of recorded it wrong, so this will be a little janky. Now the reason why it looks so bad is because the camera is trying to center itself on the head and not the torso, which, you know, while you're rolling around, your head's kind of bumbling around the place, so it isn't very nice to look at. But by using this itty bitty single line of code, I can simply change the camera subject from the player's head to the ball, making everything so much nicer. So with a couple scripts and parts, we now have our ball rolling around. Now let's get a look at how other players can see this. In Roblox Studio, you can actually enable a second view called the server view, which basically just shows how the server sees everything. Now this isn't exactly the same as other players, but since our current functions are super simple, it'll do for now. So let's go into it, and where is my character? Oh, it's at spawn. Okay, let's talk script types. Huge rant incoming. There are 3 script types: server script, local or client script, and module script. We don't have to worry about the module scripts since they aren't ever used, so let's stick to server and local. So let's get into how a Roblox game actually works. There are 2 components we're going to focus on: the client and the server. When launching into a game on Roblox, your device, which is called the client, actually connects to Roblox's server, which is why internet is required even if the game you're playing should be single player. Now, the client and server have a major difference in that one runs and manages the whole game, which is the server, while the other only manages the player on the device, which is the client or local. Now, the server script is easy. Whatever is put there, the server will see and adjust accordingly for all players. So say we have this script, which takes a staircase from the server storage and clones it to the world. Because it's a server script, the server sees this as an object and updates it, so all players see it. Now, for the local script demonstration, we have two players, P1 and P2. And only P1 has the local script, which is doing the same thing, cloning a staircase from replicated storage this time. When the local script runs, P1 sees the change as usual, but the server, not P2, can, and basically only sees P1 floating. This is because the local script only works for the player's individual client. Now let's look at our script. We see that it's a local. Because the script only runs on the client, their client is the only one that's affected. Okay, rant over. Now how do we overcome this obstacle? It's pretty simple really, since the ball replication is in a local script and the server doesn't see it, we can simply just move that code to a server script and have an event run the code when the ball time button is pressed. And in the local script, wait until the server clones the new ball to the player. Now when I go to the server view, you can see the ball is there and rolling around. Okay, but wait, I went on a whole rant about how local scripts can only affect what the player sees and doesn't affect the server in any way. So why is it when the local script changes the ball's speed, the server actually sees it? So this may get a bit complicated. So remember how I said if a local script does anything, the server won't see it? Well, this is thrown out the window in regards to the player. So let's say a local script moves the player character over by 10 stats, and the server doesn't recognize this or synchronize the position. Now we have desynced players who's somewhere on their screen but in a completely different spot on everyone else's. The server doesn't like that and it could cause some issues, so Roblox implemented that any changes made to the player's character is synced to the server, regardless of the script type. Okay, but why then did the first test have the player standing still on the server's view but not on the client view? You may be asking. Well, that's because the local script creates and applies the force to the ball, not the player directly. And because the server doesn't see the ball or know that it's welded to the player, it assumes the player hasn't actually moved at all and doesn't synchronize the position, therefore the player remains still. But in the case of now, the ball is actually there and has force being applied to it. And because on the local script the player is actually moving, the server actually recognizes this and moves it accordingly. Let's get into the last thing I want to do. Add a mechanic where if two players collide, the faster one gets their speed halved, while the other one gets blasted away. Just for fun. For this, we will place a script inside the ball itself that detects when the ball is touched, but how do we do that? Well, parts can detect if they're being touched by another part, with the .touched event. Using this, we can get code to run when the part is touched. And we can also see what part touched it. Now we just have to filter out which part we actually want. To do this, let's check if the part touched name is ball, which is what everyone else's will be named. And let's duplicate the current ball and place it into world just for testing purposes. Now when we touch the ball, it gives a ball touched output on the bottom, while everything else gives a not ball touched sad face. Now let's add a cooldown so it isn't spamming the ball touched. To do this, we can add a variable called cooldown, which is false for now, but when the code is ran for the ball being touched, it will run the code, but sets the cooldown to true and waits 1 second before setting it back to false. And while cooldown is set to true, the code will not run. So remember the assembly linear velocity, or just velocity, and its magnitude earlier? Using the same variables, we can see which of the two balls is moving faster and apply the faster ball's velocity to the slower ball's velocity by 3 times and halving the faster ball's speed, making the impact explosive. Now let's add some flair to this by adding a custom bonk particle. I've already drawn up the texture for it, and now it's just a matter of implementing it into the game. First we start with a particle emitter, which, you guessed it, emits particles. Now we can change the texture to our bonk texture, and using this neat little thing called number sequences, we can sort of animate our own particle to start medium size, grow large, then shrink down. And let's add some rotation to it to give it some more flair. Now we place that into the player's ball, and using the part touched earlier, we can make the particle emit a single time, therefore finishing our little mechanic. So you may see that the balls kind of has some weird behavior, and I don't really know how to fix it. I think this is because I had to make the velocity update via the server, which can be a little laggy at times, because it's not client-sided, but server-sided. However, I don't think it impacts anything too greatly, and can actually make for some more funnier instances. Okay, so first we have our players. This is basically just so we can get to our player. Then we have replicated storage, which is where our ball is held, and run service, which basically runs everything. But we want it now, just so we can run this piece of code every single frame. Then we get the button, which is the script is currently a child of, and obviously what we want to be pressed. And we also have the player, just to get the current local player. Local ball is just the ball that's currently being held in replicated storage, that is our marble. And char is the player's character, char's just kind of shortening it, which either gets the player's character, or if it's not there, it waits until the character is added. Then we get the hum root, which, as I said before, is the humanoid root from the player's character, and we also get the hum, which refers to the humanoid, as you can see by these two wait for childs. Then we also get the camera from the workspace, which is the player's current camera. We have a variable called baller, which I will get into later, and we also have a ball time event, which I will also get into later. Actually, I guess I'm getting into it now. So of course we have that button, and when it's activated, it will connect a function. So you can see here, it's pretty sequential, button. When it's activated, it connects a function, which fires the ball time event. Now, when this actually fires, it'll wait until whatever code is currently ran from that is finished firing. So let's quickly jump over to that piece of code right now. So we'll find this code in server-script service called server ball time. And basically, this also grabs our replicated storage for our ball, and also the event used to trigger the code. And you can see with the event, when it's on server event, it'll connect a function. This player here basically just tells the script which player actually triggered it. Since this is a local script, triggering into a server script, we can actually get which player this script is from, which is very helpful for what we need next, because we need the player character, so we just get the player's character, and the player's hum root, which we get again from the player's character. Then we create a new ball, which is basically the ball from replicated storage, cloned, and a new world, creating a new world, as you can see here by this instance.new. The new ball's parent is set into the player's character, which I will show later, and its position is set to the player's humanoid root position plus vector3.new 3 studs in the y-axis. So this basically makes it so the ball isn't set into the floor at all and is actually set a little bit higher than the player. Now the new world, we parent it to the player's character just to have it somewhere, and we set the part 0 to the new ball and the part 1 to the player hum root. Now as I explained earlier, a world basically sticks 2 things together, so this is kind of like the glue that holds it all together. And without this, the ball would just kind of roll away from the player, and it would be kind of sad. So now that we've got this done, we can go back to our local script, and we can see that the player ball is currently waiting for that ball to be cloned. So character, wait for child ball. So whilst it's on this line, it won't do anything until server ball time creates the new ball and parents it to the player character. And that's when the humanoid platform stand will equal true, which remember will quote unquote trip our player, and the camera subject is set to the player ball so that it's not nauseating to play, and baller equals true. So now this value equals true. Now we get to run service.heartbeat. Now you can see our baller value here. The reason why it's here is because we don't want any of these scripts to run unless the ball is there. So what this baller does, is baller variable does, is while it's false, it does not run this code. So by default, it's false, and therefore there is no ball. But once the ball is here, baller is set to true, and so whenever a heartbeat gets triggered, which is basically every frame, the baller is, true, so then it'll run all of this code. So first it detects if the humanoid health is 0. Now this currently helps save from a lot of errors, because when you fall into the void in Roblox, it completely deletes everything, including the ball. And if this code is running here, it'll error out a lot. So this is what this is currently for. It'll simply return, which basically means halt the code and completely stop it. But if the humanoid doesn't equal 0, then it'll first find the ball in the character and check if the ball's assembly linear velocity is above 20, the magnitude, like we said earlier. So this is basically checking, is the player slow or is it going fast? And if the player is slow, then the assembly linear velocity will equal the hum move direction multiplied by 3. But if it's above 20, then it'll simply equal the hum move direction multiplied by 1.5. So not as fast as if it's going slow, but it's still there. Now, the last script that is currently in this game is the ball bonk. Now, of course, again, we have the ball, which is currently the script.parent this time. Because if we look here on the left side, on the right side, you have replicated storage, you have the ball, which is what we're copying from, the particle, and the script. So we can actually just grab this script.parent. And of course, we have cooldown equals false for now, which we'll be getting into later. And we also have the particle, which is just the bonk particle. Now, every time it's touched, we get the part, and we check if the part's name equals ball. Because, if it equals ball, then it's obviously another player's ball. And if cooldown equals true, then return. Now, a neat little thing you can do is usually you'd see if something equals something, then, you know, do something. So like, if cooldown equals true, then return. This completely works, but this works in the same way. And it's the same reason, it's also the same sort of thing where cooldown equals false equals, and if not cooldown. It's really neat, and when I learned about it, it was actually pretty cool to use because it sort of helped tidy everything, if you know what I mean. Now we check the current ball's magnitude against the opposing ball's magnitude. So we can see if the current ball's magnitude is bigger than the opposing ball's, then the opposing balls will equal the current ball's velocity by multiplied by 3, and the current ball's velocity will be halved. Which I know is kind of a word scramble, and I'm hoping just by reading this you'll understand. But yeah, basically opposing ball's velocity equals the current ball's velocity multiplied by 3. But if the current ball does not have a higher magnitude and is instead going slower, then our current ball's velocity equals the opposing ball's multiplied by 3, and the opposing ball's velocity is halved. Now, there's one issue this could run into where, obviously, because both balls have this script, it'll both run, which could mean the slower ball gets sent way further, and the faster ball, you know, gets the speed halved twice, which could be bad, but, you know, it's pretty benign, basically, is what I'm saying. Now, we can see here, particle, going back to bonk particle, it emits once, so whatever this number is, it'll emit that number of times, but, you know, it's 1, we only need 1. It'll then set the cooldown to true, and wait 1 second before sending it back to false. So basically, this means once it sets it to true, you know, this will become true and it'll halt the code. So it waits a second before allowing anything else to run, and then loops that. It's kind of amazing how little code this actually took. I mean, there's only really 3 scripts here. The bonk, the ball time for the server, and the local ball time. I mean, there's only 39 lines in this one, which is currently the biggest script. It's probably even under like, what, 48 there? It's under 100 lines just to have our little game, which I think is absolutely beautiful to have all this. So that's just a quick breakdown on how the code works, just so you can sort of take in how everything operates, you know, sequentially, and sort of also how everything works together. But yeah, that's all I really wanted to show in this little segment. I hope you enjoyed it. I mean, in future videos, I think I'll keep doing this because it's kind of fun for me to do as well. And it also pads down, it also pads that runtime, you know, making like a further video longer. I'm not getting paid. Anyways, yeah, so, you know, hope you had fun with this little segment. And so now we've come to an end. Now we have our ball. We be rolling, jumping, and slamming into the others. This was a really fun project to work on, and I hope you enjoyed the ride as well. Even if it is finished now, I will still look for comments adding on to the game, and will probably even make some more adjustments of my own. And hey, I may even return to it, since I think there could be some pretty fun mini games to be made with what we have now. I do hope you enjoyed watching this project as much as I have created it. Also, you can play the game, it is on Roblox, I'll leave a link to it below, and I do hope to see you all later. But until then, Have fun creating your own games, and I'll see you all next time.